Spray foam insulation and subterranean termites in basements and crawl spaces. A comfortable and efficient home must keep the inside air in and the outside air out. According to the U.S. Department of Energy, unwanted air leakage can account for up to 40% the cost of heating and cooling a home. The walls, ceilings, and floors we build are constantly subjected to air pressure differences, resulting in outside air infiltrating into the building enclosure, while the inside air is exfiltrated to the exterior. These pressure differences can be caused by wind loads, which can vary by height, exposure, and site conditions. Other sources of air infiltration and exfiltration are HVAC systems and exhaust fans, which can be mitigated through proper location and design of the HVAC system. The third cause of air leakage is known as the stack effect. As warm interior air rises, it develops outward pressure on the upper elements of the structure, while placing inward pressure on the lower elements. Regardless of exposure, climate, or design, this effect occurs 24/7 in all buildings. The upward movement and exfiltration of air up high results in unconditioned exterior air being sucked in at lower levels, mostly through the gaps, cracks, and openings at the foundation framing interface. The best way to reduce air exfiltration and infiltration in a building from the stack effect is to eliminate all cracks, gaps, and openings in the ceiling and at the framing foundation interface. Shown here is the typical air infiltration paths at the foundation framing interface. Aside from penetrations from piping and wiring, air infiltration occurs at the gap between the bottom of the sill plate and the top of the foundation wall, the gap between the bottom of the rim joist and the top of the sill plate, and the gap between the underside of the subfloor and the top of the rim joist. Reducing air infiltration at these locations is critical to achieving building air leakage limits required by current building and energy codes. It should be noted that during the winter in cold climates, the stack effect drives cold, dry air into the building here. The stack effect also drives warm, moist air into the building during summer months. In warm, humid climates where air conditioning is used, infiltration of hot, humid air at the framing foundation interface can condense on the sill plate, rim joist, and adjacent framing, resulting in ideal conditions for wood-destroying organisms like mold, mildew, and termites. There are several strategies available to insulate and air seal the framing foundation interface. One option is to seal these gaps with caulk and sealant and insulate the rim joist with a fiberglass bat. Unfortunately, the labor required to properly caulk and seal the perimeter of the rim joist between each floor joist is costly and tedious. Additionally, it may be impossible to caulk and seal the rim joist gaps where the floor joists are parallel and spaced closely to the rim joists. Another option is to cut foam board insulation to fit between each floor joist and seal the perimeter of the foam board. While this is effective, it requires significant time and labor. The most cost-effective means to insulate and air seal the rim joist is spray polyurethane foam insulation. The product is applied as a liquid or froth, which expands into a solid foam that provides air sealing and insulation of the foundation framing interface in a single step. SPF can also be used below the floor for an unconditioned basement. A vented, unconditioned crawl space or basement may be preferred when there are no HVAC equipment or ductwork in the space. In this situation, SPF can be applied below the subfloor, leaving the foundation framing interface completely exposed. Insulating below the subfloor requires significantly more insulation, conceals piping and wiring, and may leave cold floor joists exposed to hot, moist air during the summer, which can result in condensation, mold, and mildew. SPF can be extended down the inside of the foundation wall to create a conditioned basement or crawl space. When closed cell SPF is used, it can provide a code-compliant vapor retarder as well as a FEMA-approved water-resistant insulation required in flood-prone areas. Conditioned basements and crawl spaces result in more energy-efficient buildings when HVAC and ductwork are in the basement or crawl space by bringing this equipment into the conditioned space of the building. Pest management professionals have some concerns about the use of SPF in conditioned attics and crawl spaces. Pest management professionals need to perform regular visual inspections of the framing foundation interface to detect early evidence of termites and other wood-destroying insects. These visual inspections include checking for mud tubes from subterranean termites on the inside of the foundation wall, as well as poking and prodding the sill plate for early termite damage. Any indications of termite damage detected during these regular visual inspections typically result in the implementation of a treatment program by the pest management professional. If SPF is applied continuously from the bottom of the subfloor over the rim joist and sill plate and down the foundation wall, pest management professionals cannot conduct a visual inspection. In regions where subterranean termites are a problem, SPF and other permanently installed installations should not cover the side of the sill plate up to the top 3 inches of the wall. This enables pest management professionals to perform the necessary visual inspections. It should be noted that building codes in several states in the southeastern U.S. require that these areas be exposed for visual inspection. SPF can still be used to insulate and air seal the foundation framing interface. Here is an application of SPF on the inside surface of the rim joist. This single-step installation provides insulation and seals the gaps between the bottom of the rim joist and the top of the sill plate and the underside of the subfloor and the top of the rim joist. The side of the sill plate and the top 3 inches of the foundation wall are not covered with SPF. While this is not ideal from an insulation perspective, it does facilitate visual inspection for termites. Note that the gap between the bottom of the sill plate and the top of the foundation can be sealed with caulk or foam sealants. If the foundation wall is made from CMU block and the top course has open cores, sheet metal flashing can be inserted to cover the core openings. The flashing can then be sealed to the sill plate on the top and sealed to the foundation on the bottom. Some pest management professionals believe that the use of removable fiberglass bats provide the best option for visual inspection of the rim joist instead of permanently installed foam board or SPF. Aside from the labor-intensive sealing required for removable bats, repeated removal and reinstallation of these fiberglass bats will ultimately damage this type of installation over time. Pest management professionals are not trained in the proper installation of fiberglass bats and may not reinstall the fiberglass bats in Grade 1 condition required by residential energy efficiency programs like Energy Star. SPF provides the most cost-effective means to properly insulate and air seal the framing foundation interface. Installation options are available to provide a complete visual inspection of the sill plate and the top edge of the foundation. For more information, contact the Spray Polyurethane Foam Alliance or the Center for the Polyurethanes Industry Spray Foam Coalition. To obtain free copies of this document, visit sprayfoam.org.